We are
Hello
live.
and welcome everyone to the first live streamed user group meetup of the WPNinjas user group Germany. Happy to have you all. Today we are joined by two fabulous speakers talking about very interesting topics that you won't easily find anywhere else at the moment. For one, we have Christoph Hannebauer. He will show us a little bit about how to manage your certificates with Intune, but not the normal way. We're talking about Linux clients. What? So take a look and stay there. Christoph will start very soon. And then Thomas Verheyden, he will show us, give us an overview about Microsoft Security Exposure Management in Microsoft Defender XDR. Stay to see why this is important and why it's not only the Defender for Endpoint that you should think about. It's a lot more, I can tell you. So welcome again. Enjoy the session. And whenever you have questions, you can bring them into the chat. And then Ugo will take them over and talk to Thomas and Christoph. So bring in your comments, bring in your questions, have a lot of fun. And stage is yours, Christoph.
Thank you. So, yeah, I'm very pleased that I can be here and take over the first session this evening. Yeah, thank you for the introduction. Also, I'm Christoph Hannebauer, and yeah, I will show you a journey on how we struggled and finally succeeded to enroll certificates on Linux devices with Intune. So first, a few words about me. I work on Kanya for more than 20 years now, and I've always been involved in public key infrastructures and cryptography. I'm the head developer of one PKI product, the Scapman, and it will show up in one or two places in the presentation. And yeah, I got a couple of certifications. My hobbies are among other things, apples, but not the electronic ones, but I have few apple trees that I can take care of. And you can contact me via email or via Teams if we are federated. Okay, what we'll be looking in this session will be first a quick recap. How can you enroll certificates with Intune on normal platforms, also everything but Linux, Windows, Android, and so on. And then we will have a look how we can manage Linux clients with Intune and how we can hopefully apply this certificate distribution methods that we have in the other platforms to Linux. And yeah, as a spoiler, it won't work so easily. So we'll have a look at alternative enrollment protocols. And finally, I'll show you a way how to do it with EST. And hopefully after the session, you will have some insight generally on how Intune and Linux work together and how you can solve some problems that occur along the way. And of course, I'll show you a small demo of how this works together, this certificate enrollment to Linux stuff. Okay, so as I said, first recap. How does certificate enrollment work for Windows, iOS, macOS, and so on? So first, a very traditional approach with on-prem infrastructure. You have the Microsoft CAA, the AD certificate services, and then you have some clients that you manage via Intune. And then in Intune, you configure a SCAP configuration profile. And that tells the clients they should enroll for a certificate via the SCAP protocol, the simple certificate enrollment protocol. And what the SCAP what the clients will do then if such a profile is configured and they are in scope, they will generate a key pair, cryptographic key pair, a certificate signing request, and they will send it to a URL that's in the SCAP configuration profile. In this case now, that would be an NDAS server. That's Microsoft on-prem implementation of a SCAP service. And then what the NDAS does is it will send the CSR over to Intune, which says, yes, that CSR is okay. And this actually comes from Intune. And so NDES knows then that this is okay, the CSR. You can issue the certificate and send it back to the client. Okay, now the client has the certificate and it can do whatever it wants to do with this, probably some network authentication. And now in more modern times, the process is exactly the same if you use a cloud client, like we have one Scapman, but it's actually the same for the cloud PKI from Microsoft, for example, or others. Intune has this API and it behaves exactly the same. The CSR sent to the SCAP service in the cloud, it will validate with Intune and it will issue the certificate. Okay, so this works for Windows, for Android, for iOS, for macOS. Can it work for Linux too? So let's have a look at how Linux clients are managed with Intune. So this is the non-Linux clients you have. If you set up a configuration profile, you have lots of templates that offer you a lot of things. I've counted this, the number it had today in my lab 10, it was 27 different templates. One of them is the SCAP certificate. And if you select this, you have various options on how the certificate should look like that is enrolled via SCAP, what should be in the subject, the extended key usages, and so on. And this offers a convenient way to control settings on how the certificate should look like. We have another option that also allows certificate enrollment. It's the PKCS certificate option that does also work for other circumstances. It depends on what you want to do. But in all cases, you can select a lot of stuff. So this is Windows and Android and so on is similar. The SCAP configuration profile is available for all platforms, but is it also available on Linux? How many templates do we have here? Is it less than 27? Maybe only 20 or 15? Well, on Linux, we have 0 templates. There's no template at all. You have no configuration profiles that you can select from. The only thing that you can do is this. You can paste the bash script. And I mean, it does execute regularly. You can select a frequency, but you don't even have some magic variables that you can insert, like that Intune would insert some token into the script or some device ID or something. That's all not possible. You can only select one bash script and it's applied to all Linux machines in scope. So yeah, that's not a lot, but then again, it's a bash script. You can do a lot in bash. So maybe we can do it here. And maybe since we don't have it in a pre-configured way, maybe we can just rebuild whatever the Intune clients do on the other platforms and do the same thing. Maybe that works. So let's have a look at whether we can do that. And for this, let's have a deeper look at the enrollment protocols and especially start with SCAP because that's what the other platforms are doing. How does a SCAP request look like? Technically, that is actually a PKCS7. So it's it's a format where that can be encrypted and signed, and this is the case in the SCAP request. It's encrypted against the CA, and it is signed by the private key that was just generated. And inside there's a payload, and this is actually a PKCS10, so it's a certificate signing request. And what it contains is different values that the requester wants to be in the certificate. For example, the subject. When we are talking about Intune, you configure the subject in the SCAP configuration profile. You can have some variables in there, for example, device name, and then the client inserts the actual device name. And what, of course, is also in there, the public key that is supposed to go into the certificate that corresponds to the private key that was generated on the client. And then there are a couple of extensions. So, for example, what the client wants as validity period. Of course, the certification authority has the last word on this, but it's what the client wants. This is also something that you configure in the SCAP configuration profile in Intune, and some other stuff. And most importantly, the challenge password. This is because anybody could send a SCAP request to a SCAP service as long as it's not protected by a firewall or so. So anybody could send this, could encrypt it to the CA certificate and send this there. So the SCAP service must decide when it receives such a SCAP request, is this a genuine request? Should it issue a certificate for this? Or is this an attack or something? Or yeah, and the difference is what makes the difference is the challenge password. And a simple way to deal with the challenge password, because SCAP is specified in an RFC, but it just says the challenge password must be negotiated out of band. So the standard itself doesn't say where the challenge password come from. This is something that each implementation must decide. And an obvious way to do it is just have one static password that is used for all SCAP requests. And if it's correct, then the SCAP service will issue the certificate. And if it's incorrect, then it won't do that. However, this is obviously not the most secure way to do it. If you do it it depends on your use case, but in the use case where, like ours that we discussed, the Linux clients must generate the SCAP request. So if it's always the same password, then every Linux client must know it, and then you couldn't differentiate it. If Linux client sends a SCAP request and says, I want it for user B, but it's actually user A, then the SCAP service couldn't differentiate it. The challenge password is correct. So the static challenge password is our last resort like that, but it's not a very good way. So how does Intune do it? Let's have a look into one password that Intune put into one challenge, and the standard doesn't only not say what the challenge password should be. Obviously, there's also no length limitation, so it can be very long. This is base64 encoded, and inside there's this XML. For the younger ones in the audience, XML is like JSON, but just for old people. So, and what's in that XML file is some metadata, and most importantly, there is a signature in there, and this XML is signed by a certificate that the Intune service itself owns, and then there's some actual payload, and it's encrypted to another certificate that Intune owns. So what this does is Intune can tell the clients to create a CSR. It will say, use that challenge password, and it can add into this challenge password metadata that say, the certificate should look like this and that. I expect this extended key usages, this subject alternative names, properties of the certificate. And then when another Intune service is about to validate the CSR, it can compare, is the data that is requested in the CSR the same as those we expect it to be? Is this all valid and genuine? And then it compare this and say, yes, this is a good request. Dear SCAP service, please issue the certificate, or no, there's something bogus in here, don't issue the certificate. Yeah, well, the signature, because it's made by a Microsoft-owned certificate that's in the Intune service, we cannot create this challenge password. So on a Linux client, we cannot actually create this challenge because it's only possible to do it if there's a SCAP configuration profile. If there's no SCAP configuration profile, there's no Intune that generates this challenge. Okay, so this is a dead end. We cannot do it exactly the same way on Linux as we do it for the other platforms. So if this doesn't work, then let's have a look at other certificate enrollment protocols. There's actually a lot of them. So one one important protocol is the auto enrollment that on-prem AD environments are used. It's over DCOM. And this is if you have an on-prem AD Active Directory environment, this is the protocol that the clients speak with a Microsoft CA when they talk directly. And it's a very good protocol if you have an on-prem AD environment, Windows machines. But in this case, we don't have Windows machines and they are no AD joined. So this is not really an option. Then we have ACME. ACME is also a very nice protocol. It's widely used and you've probably used it before, but maybe you don't know the name. Maybe you do. It was invented by Let's Encrypt, and this is what they use to automatically enroll certificates for web services. Nowadays, it's also used in some other places, but the original idea was to enroll certificates for web servers. And that shows there's also an RFC for this, and it shows in the RFC the way you validate that a request is genuine and that the certificate should be issued. There's always a proof of ownership of some kind of website, at least a domain name or an actual web server. And the domain name is a key part. And for our Linux clients, we don't actually have, they don't have really necessarily control of domain names. So it will be hard to use ACME for this. About SCAP, we've already talked. It's the de facto standard for MDMs. All MDMs that I know of support SCAP, including, of course, Intune with different implementations, sometimes the static password thing, sometimes or for Intune, the more sophisticated stuff. But yeah, we have looked at this. The static password or some variant of this might be a way, but as I said, it's not so easy. Then we could do it by hand for each Linux client, and it's actually a plausible solution in my opinion. If you have a big organization, many devices, but only 3 of them are Linux devices, and it's special, then it's probably not a bad idea to just create a certificate manually through some website that your PKI offers and put the certificates on the 3 clients manually. But if it's more than that, we might need a different solution. And the one protocol here is the enrollment over secure transport, EST, which is similar to REST API. Maybe your PKI also has a REST API, and such an API can be used for more large-scale deployments that still need some custom handling. So maybe this is something we can use. And so let's have a look. So how does EST work? Maybe we can use that. It was invented by Cisco, which also invented SCAP, and Cisco thought it would be a good successor of SCAP. They thought SCAP wouldn't be such a good protocol, and after they have invented this, SCAP became really successful. All MDMs, as I said, that I know do support SCAP, and none of them does support EST. So SCAP was far more successful than Cisco believed, I guess. But still, EST has some nice features that maybe we can make use of. And especially it has a REST-like interface with different commands. 2 of them I want to highlight here especially, simple enroll and simple re-enroll. Simple re-enroll is actually also all small caps, but yeah, because it's difficult to see, I wrote them in big caps here to show the difference. And it defines different authentication methods to authorize the certificate signing request and to make sure to allow the CA to decide whether a certificate should be signed or not. And let's look at the simple re-enroll first, because that fits good with the dramaturgy of my presentation. So in this case, there's an EST server and an EST client. And the EST client must already have some kind of certificate with a private key, but it could, for example, be close to expiration. And once the EST client has something, it can generate a new key pair, a new CSR, and send it to the EST server. And it sends this over an HTTPS channel, so uses TLS, but mutual TLS. And usually when you use TLS, most of the time, only the server authenticates itself with the server certificate. But with mutual TLS, also the client does a client certificate authentication and also proves that it also owns a specific certificate. And in this case, it uses the old client certificate. And then the EST server, it sees that this it sees with which certificate the EST client authenticated, and it can then decide, is this enough or what is it? In the case of Skypeman, which also supports this enrollment method, we made it that that the new certificate must look exactly like the old certificate, just that it is valid for longer. So it is used for renewing a certificate. And that's also very interesting because the initial enrollment is one part, but renewing is another. So with this method, it's very easy to renew a certificate once you have the first certificate on the client. For example, if you do it manually on the Linux client. But of course, it doesn't really solve our problem of enrolling the initial certificate. But wait, on a Windows client, if it's Intune managed, if you would take a look at the machine store of the certificates, you will find a certificate that looks similar to this one. So it is a certificate that is issued by a Microsoft Intune MDM device CA, and it's issued to some GUID, which is actually the device, the device ID your device has in Intune. So with this certificate, you can prove that the certificate where this is on is actually a device managed in Intune, and it can prove which device it is. And this is actually used in the background to, when your device authenticates against Intune, to show which device it is. This is the way it does it. It uses this certificate. But since it's on the computer, maybe we can also use it for the EST enrollment, because the simple re-enroll method doesn't say in the standard what exactly are the properties that this certificate could have. So maybe we can use this on the client to exchange our Intune certificate that's already on there for a real certificate from your PKI that you can use for authentication methods to, for example, authenticate on the Wi-Fi or on your network. So when we look at a Linux client that is mentioned in Intune, in the keyring, we actually find a couple of entries for Intune, and there's also one of those contains a secret RSA key. So obviously it works similarly. And one of those entries also contains a key named signed cert, but it's actually empty. I'm not sure how this came to be. Maybe they planned this differently initially, or I don't know. But bottom line is there's no certificate and there's no way to identify what the RSA key, what machine this RSA key corresponds to. So that looks like another dead end. But hey, EST has another method, the simple enroll. So, I mean, the renewal we have already kind of solved with a simple re-enroll, but maybe the simple enroll can help us to enroll a certificate initially. So how does that work? The EST client in this case generates a CSR and sends it to the EST server and uses just in the post request that it does to the simple enroll a basic authentication. Now, basic authentication, it has its problems. So I mean, it's a not very secure way, and you need some username password pair. And what would that be? The Entra credentials, and you send them in a clear text to the server. It's not very nice. So um, it would work if we could find such credentials, but I don't know what that would be on our Linux client. So when we were at this point, what we thought is, yeah, we have OpenID Connect with Entra. Why don't we use that on the EST client, on the Linux client? We have already the Intune portal installed. There's the credentials there. So why not use that? So in our case here, we have a user Alice on the EST client XYZ, and we have a bash script that is also available for download. It's open source. And with this script, it makes the user log on to Entra with the user credentials. And then it gets a bearer token. And with this, the script generates a key pair and a CSR and sends this to the EST service. In this case, the only compatible service that there is so far is Scapman, and uses this bearer authentication from OpenID Connect to authenticate the request and then send the CSR there. And now Scapman knows which user is logged on, in this case Alice, and it gets the certificate signing request. And now Scapman can ask Entra ID who the user is. So yeah, who's Alice? And in Entra, of course has a user account for Alice. It also has a device for XYZ because it's Intune managed. It can be either in Entra itself or in Intune. But in any case, there's a primary user for this device, and this is Alice. And so this can, in this case, Capman find out. And since it knows the Alice is logged on, in the CSR, there's a request for the client XYZ or maybe for Alice itself. And then it can enroll a corresponding certificate, issue a certificate for XYZ, so for the client. And then the client can use the certificate. And now have a look how this looks like in practice. I have a Linux machine over here. Okay, so this is the home directory. We'll later enroll the certificates to here. So this will happen later on. Now there is no certificate here. It will enroll to a certs directory. And how do we do it? This is the repository that I was talking about, the Scapman CSR request. And here we have the script that I was talking about. Yeah, this script, if you execute it, it will take a couple of arguments and so on. You can do lots of things with it, and you can enroll certificates also to Linux clients that are not Intune managed. But if you want to do it on an Intune managed Linux client, which makes it very convenient, you cannot actually pass any commands in Intune, as we'll see in a second. So what we'll have to do is prepare this a bit. So let's paste this into Visual Studio Code, and then we'll have to modify here at the beginning the part where it reads the parameters from the arguments. And I've actually prepared something here. So these are the 5 lines that you have to replace. You have to enter the URL of the EST service, an API scope that is used for the Entra login, and then this is where the certificates should be placed on the Linux client, and that's it. Okay, and yeah, one more thing. Currently, there's a user certificate. That's okay, but you could also use a device certificate. So maybe let's use a device certificate. Okay, I'll copy this and go to my my Intune. Here's Linux. You see, we can have compliance scripts, which is also a nice thing, but not out of scope. And here I've already some test scripts in this environment, but they are all not assigned. So I create a new one and say enroll certificates Ninja group, and I'll paste the script here. You can actually upload a file, but it's not any different because it will also just paste the script here in this text box. So yeah, that's the way to go. And what the script does is it does the initial enrollment, but if it detects that the certificate is already there, it will instead wait until close before expiration. And if it's close before expiration, it will renew the certificate via the simple re-enroll method that I've presented. So we'll execute it every 6 hours, and then it will get either a new certificate or make sure that the existing certificate is renewed before it expires. So this will make sure that the client will always have a valid current certificate. Okay, let's try this. We'll assign it to all of them, all Linux devices, and create this. Okay. We have a new configuration script for Linux. And now let's have a look here. I'm here already enrolled to Intune on this Linux machine. I click refresh, which always triggers fetching new configuration profiles and executes them, hopefully. I think it didn't yet do it, but let's have a look. No, nothing yet there. Hopefully it does it now, or the demo gods are not with me. Let's try one more time. Oh, no, that's not really better. I'll try to restart the Intune client. Maybe that helps. Okay, it wants me to sign in once more. So let's just do that. The reason I'm quite sure it didn't yet work is the first time, as you've seen, Alice needs to log in to Entra, and there was no pop-up requiring me to do this. I'm afraid it doesn't work. Maybe it's some latency issue. I'm not sure. I'm quite sure it will. Oh yeah, now it works. Okay, so now in the background our script executed and it wants us to log in to Entra. So there's a user interaction which I do not like so much, but it only happens the first time a certificate is enrolled. So you do whatever you have configured. You can use your usual authentication methods, also passwordless. I'm having here password in a demo environment, but usually you can do also passwordless, or you can do any kind of conditional access policies that you like, and they are then used for the first login. And now in the background, the script has executed, and let's see, hopefully it has worked. Yeah, we have a certs directory. This is what we had configured in the script. And let's have a look. Yeah, there's a certificate, there's a private key. There's a certificate, the private key, and the root certificate also. And yeah, now this client has a certificate. That was it on the, I mean, was after all 3 minutes of configuration, 5 minutes of waiting, and on the client side, it was, yeah, one login. And now, because it's executed every 6 hours, once the certificate expires or is close to expiration, it will automatically renew through the simple re-enroll method, and there will be no interaction anymore. So this is just this initial interaction that usually will happen once you enroll to the Linux client to Intune. And yeah, that's it. So, okay, as a summary. Yeah, usually enrolling certificates with Intune is quite easy, but Linux is more difficult. We struggle to get a working way, but with EST, eventually there's a quite good solution. It's an open standard also used here with EST. If you also want to do this, we have this bash script, and Scapman is a compatible certification authority that allows you to use this. And to generalize the learnings that we've made here, I think that managing Linux clients with Intune, it can be done. And I think it depends on the use case. If you have only, like I said, 3 of them, maybe it's easier to just treat them very manually. Then there's some interval, I'm not sure how large it is, where it makes sense to manage this Linux clients with Intune if you already have Intune, because, for example, you manage all your other platforms there. And if it's a certain amount of Linux clients, you're probably needing another more professional solution. That's my guess. But if you are in this area, you have some special clients on Linux that and you are using Intune for everything else, then I think it's a good idea. Also for the compliance scripts, so your Linux clients are also compliant. You don't need to exclude anything from your conditional access policies. You have only compliant devices in your environment. And with this tools here, you can enroll certificates very conveniently on your Linux clients, make them very easily join your network. You don't have to rely on any insecure authentication methods to let your Linux clients connect to your corporate Wi-Fi. And yeah, you have less exceptions in your organization and more standards. So thank you for your attention, and that was it from my part. Maybe somebody has some questions and were collectively from.
Yeah, I was checking the chats on YouTube and LinkedIn. I didn't see any question.
That's my presentation explained everything.
Absolutely.
It did for me.
Christoph, thank you very much. Very interesting topic. I like the way that you were thinking there, because this is basically what makes IT fun, isn't it? There's a thing and it works on this thing, and you want to work it on that other thing, and you have to find a way how to make it work. So kudos to really getting that way of managing certificates in Linux with that way around it. Really, really, really cool. I have a question, actually. Do you really have like real world experience with some customers where this is in action?
Yeah, we have a few customers that are starting with this. So they are also using it on production environments, but I think yet on a smaller scale. That is my impression. I mean, we have it now documented publicly, so theoretically anybody could use it, but because it's relatively a new feature from our end, the Bash script, we worked on it for quite a while, but we published it only recently in a version that can really be used. And yeah, we had a couple of questions from customers that are trying this, and we had very positive feedback, but I think not on a large scale yet.
Okay, but again, very nice idea and well done, as DR from the US said in the YouTube chat. Perfect. Christoph, thank you very much. Now let's switch over to Thomas, switching topics a little bit, but it's still all about security. Shift from vulnerability management to exposure management. Let us know what that is and have a lot of fun with your session. Thank you very much.
Yes. Let me start with sharing my screen. 1 second. All right, looks good. Okay, welcome everyone to my session about proactive security, the shift from vulnerability management to exposure management. But let's first start with a quick introduction of myself. If my slides want to go. Okay, yeah, here we go. So a quick introduction about myself. I'm Thomas Verheyden from Belgium. I'm currently working as a freelance security consultant. I have a big focus on threat detection and protection. I got some certificates, mostly security related. I got some hobbies. In the winter, you can find me on the basketball court. And in the summer, I'm one of those annoying cyclists that always ride in the middle of the road. But good for you guys, I never ride in Germany, so I cannot annoy you. You can always find me on some socials, like Blue Sky, X, but I'm currently mostly active on LinkedIn. I also write my own blogs. You can find me on verto.tech, and there I try to share everything that I'm experiencing with different clients and with different technology. It's mostly Microsoft security related. So let's start with the rise of exposure management. Where does this concept come from? What it's all about? And I would like to explain the rise with a survey from Gartner, which is already 3 years old. And according to this survey, it shows that 75% of organizations are pursuing security vendor consolidation in 2022. Vendor consolidation has some benefits for organizations, like cost-effective, and it can simplify management. But part of this vendor consolidation trend, I call it a trend, security vendors started with consolidating their own products. And Microsoft, but also other vendors, did a lot of consolidating of their products and creating what I call umbrella terms. A good example of this is Defender XDR, which was 3 years ago all separate products. And you got Defender for Endpoint, Defender for Identity, Defender for Office 365, Defender for Cloud Apps, and now they all consolidated in one term. Gartner is one of the key players of defining the threat landscape, and they mostly invent terms like XDR, but also exposure management. So let's have a look at some of those umbrella terms that are currently being used in the threat landscape. If you have a look at the reactive side, so that's during or after an attack, and we focus on the threat-centric side, and what we got over there is mostly XDR. Even now, in the last couple of months, it's more involving now in unified security operations. And what you see over there is the SIEM solution start integrating with the XDR solution. If you focus on the access-centric side, what we go over there is SASE. Very easily set, that's network security in the cloud. It's your SD-WAN, your secure web gateway, your CASB, or your firewall as a service. If you look at the proactive side, so that's before the attack, what we got over there is mostly the umbrella term Zero Trust Identity. Everyone knows it. But if you have a look at the threat-centric side, we currently had, or we didn't have an umbrella term there. So you got different products. For example, you got your vulnerability management, you got your posture management, but there was not really an integrated solution, or there wasn't really an umbrella term that covered all those solutions. And that's why they created the term exposure management. And what you see over there is that Microsoft picked it up, but also other vendors like Tenable, and they start using the term exposure management. Now let us look at the definition of exposure management. It's a platform approach to consolidate preventive security across the entire attack surface. So let's split it up, and let's start with the entire attack surface. Just how does a modern attack surface currently look? If we look at an example that everyone's using, of most organizations are using, it's vulnerability management. So what did they do in your on-prem environment? You got your servers, your endpoint, the virtual machines, and what they do over there, they do their vulnerability management. What else do we got? If you have a look at the Microsoft stack for solutions over there, we got Defender for endpoint, but also Defender vulnerability management. What else do we got? We got our public cloud. We got our infra in the cloud, and over there, what we do mostly is cloud security posture management. In the Microsoft stack, we got over there Defender for cloud. We also got the web apps or APIs, and it mostly are different teams. The AppSec teams are mostly called in organizations. And over there, we got the Defender for endpoint and also external attack surface reduction as a solution. Of course, we cannot forget our identities. We got our on-prem identity, but also in the cloud, intra-ID identities. And over there, we got identity detection and response. In products like Defender for identity and also intra-ID protection. What we also got is our SaaS security. So SaaS security posture management. We got Defender for cloud apps for that as a solution. And if not forget our OT infra or ICS, there's OT-sec, and for that we got Defender for IoT. So what you can see, we got a lot of workloads, we got a lot of findings, a lot of products that give us maybe vulnerabilities. So the exposure is really expanding, and we cannot focus just on one workload at a time. If you have a look at what kind of vulnerabilities that we can have software vulnerabilities, configuration vulnerabilities, and access vulnerabilities. And maybe you're thinking to yourself, can we just work on one of them, or one workload at a time? And the answer to that is no, because hackers don't care, and they attack weaknesses, and you need to work across the entire modern attack surface. If you have a look at the latest breaches, you will see that in the last couple of years, on every workload, you have a big breach. And even Microsoft couldn't escape of it because they had the Midnight Blizzard breach. And what I see a lot on LinkedIn, the security influencers, they're always talking about the story about the human is the weakest link. For me, what you see over here is the weakest link. You can't ignore it, and you have to do proactive security across the entire attack surface. So what else was in the definition? We need a platform, a unified platform. And for this, we need data. And we need the data from every sensor, every scanner, and we need it all in one place. So here is got an example of what's in Microsoft Security Exposure Management. I will go in detail more about it later on, but here's the currently supported data connectors. We got the Microsoft connectors, but you also got external connectors which are available. So we got our platform, we got our data, we got a bunch of findings, a bunch of vulnerabilities, maybe some misconfigurations. But what is the biggest problem with all the data if we deploy all those sensors? That's time. And we can't fix them all, or maybe Copilot or AI will resolve those findings for us, but you know that's currently not the case. So the platform needs to tell us what really matters and tell us what we need to fix first. And they need to help us manage those findings. And how do we accomplish this? What we need for this is relationship connections. We need to know how all those data are connected to each other. And let me explain this with an example. This is how today's exposure management tools of exposure management look like without a unified platform. They're all separate silos. In most organizations, it's all different teams, and we mostly think all in silos. And even vendors are also building in this because they all created separate products with totally no integrations with each other. What's the problem with this? In reality, everything is connected. And the one who knows everything is connected are those guys, the attackers. And they will take advantage of it because we work in silos and they don't work in silos, they work horizontally. So what we need to do, we need to stop thinking in silos, we're gonna start breaking those silos, and that's the really big idea behind exposure management. And what we need for this are 3 doors. We had our asset inventory, so we need to know our software, our devices, our identities, maybe cloud resources. What we also need to have is our exposure inventory. We need to know our weaknesses. That's going from the scanners for all the sensors that we have. And then we need to know the relationships. And we create the relationships by using graph. And let me explain this very easy by an example. I'm going to use a software vulnerability to land on a device. And on that device, I'm going to find, or I'm going to exploit that vulnerability, and I'm going to find credentials or token from a user. And that user or that identity I can steal, and which I can use to do lateral movement in your environment or get on another network segment. And then I got a total attack path. And this kind of exposure insights that we need, and we need those graphs. And this will change the game, how we handle all those vulnerabilities. But enough about theory, let's jump into the technology, and let's have a look at the Microsoft Security Exposure Management. So, what I told you before, we need data, and here you can see all the data that's currently supported in the Microsoft Security Exposure Management. And what also Microsoft does, it's not only import the data, but also enrich the data. And that can be about asset metadata, or configuration data, or policy state, security findings. And that's very useful if you want to do proactive hunting. But later on, more about that. So we need our data. The data is enriched. And then what we need is our platform. A unified platform. All the data comes together, and over there are the relationships being created. So you can see what the connections are between all those data points. And then we got an output. So Microsoft need to tell us what's important in the organization. They need to prioritize everything, but they also need to give us insight on how bad is our posture at the moment. And that's being done, first of all, by an attack path analysis. And the insights are given in the unified exposure insight. So exposure management, where can you find it? You can find it in the security.microsoft.com. If you can find it on the left side, very easy. Let me show it with the pointer here in exposure management. When you click on it, you will get to the overview, but what's most important is the connectors, because we need the data in our unified platform. And currently this is the supported data. We got Defender for endpoint, for identity, for cloud apps, for Office, for cloud, for vulnerability management, for OIT, and for anti-ID. You will see here that I don't have an IoT environment in my test tenant, so it's not connected. Later on, external attacks management will also be available, but that's currently in public preview and it's not totally integrated yet in the portal. What you also can do, you can start adding external connectors. Maybe your asset management is in service now, and you got a CMDB over there. Then you can import all the assets from there. There are also a lot of additional sensors or scanners available, like Wallace, Rapid7, and Tenable, and you can start importing those findings also in your platform. But one thing to keep in mind is that currently it's free to add those external connectors. But when everything goes general available, it will be a cost. It will be a consumption-based cost. And currently, we don't have prices yet from how it will be and how much it will cost. So let me quickly show a demo in the portal because critical asset management is a very important part if you want to use exposure management. So let me switch screens. Okay. So what I suggest to do, or advice I just do, is to go to the settings and go in Defender XDR. And over here you got critical asset management. And what Microsoft do for you, they start defining your assets, and they will give it a critical level predefined. They start classifying your assets. And here you can see all the assets that are currently predefined in my organization. So before you start with exposure management, I really suggest to start having a look at here and to see if that predefined classification is correct in your environment. Because I had some customers where maybe some domain controllers are not recognized, or some AD Connect servers are not recognized or badly recognized. So it's really important to have a look at it, because by default, Microsoft will give it a critical level. For example, if you have a look at our domain controllers that are tier 1 devices, so the critical level should be very high. It's also important to know that it's not a one and done process. It's a continuous process. You need to continually check, maybe quarterly or yearly or half yearly, because sometimes if you onboard new assets, they will not automatically be added to the right classification. What you see over here, you got your pending approval. And so I cannot show you in a demo environment, but it can be that you have a pending approval. So sometimes Microsoft, for example, finds another or a new domain controller. Then you first need to approve that, and then it will be added to the right classification. And that's also very important that you don't forget about that. And also sometimes you have servers, or for example, that are for your environment very critical. So you can always change the critical level. For example, here, IT devices, for me, it's more important, I think, in most organizations. So I would like to put it in very high. And I can put it in, and can save it, and now it's the new critical level, very high. It's also very important to do this because Microsoft determined their attack paths on the critical level. So later on, I will demonstrate that. Okay, let's switch back to my PowerPoint slides. So let's start with the attack path. What is the attack path all about? So if you click on the attack path, you will get an overview of all the current top 5 attack scenarios and also the top 5 choke points. You also see an attack path over time. So the red line is the on-prem environment. We also got a blue line and a purple line. The purple line is a hybrid environment. The blue line is the cloud environment. What you also got is the top targets. As you can see in this example, there are a lot of attack paths available. And there is also a top top target type available in the attack path. So now let's have a look at the top 5 attack paths. And it looks like this in my environment. I hope it's readable. But yeah, you can see over here that it's always start with a device that has a high severity vulnerability. That's also important to understand. So this is really related to an exposure management. What you got maybe with Bloodhound or with Azure Hound, they are mostly focusing on privilege escalation, and they are creating attack paths maybe on privilege escalations. But this is really mostly focused on exposure management. And that's the real difference between the products. As you can see over here, it can be cloud related. So as an Azure VM with a remote goods execution vulnerability, but it can also be on-premise, but it can also be hybrid. And this example is with a storage account. So it's an attack path to a storage account that starts with a device that's on-premise. And let's explain it more in detail a bit in a basic example. Let's have a look at an attack path from a high severity vulnerability on a device to a domain controller. As you can see over here, there are a lot of attack paths available. What distribution do you get? You get the critical level, of course, because the target is a domain controller, so it's very critical. You can see when it first was seen and when it last was seen. The state can be new and active, or maybe also inactive. If you resolve that attack path, that attack path will go in inactive state. And let's have a look at the next example. So this is the more detailed about the attack path. And what you see over here is we got a device which has credentials. So the device is an entity or a node. Has credential is the relationship. That's the type of relationships I was talking about. So this device has credentials of a user account. What you can see here is additional fields. Additional fields is very important. There's morely the raw data that's available. So I told you before, and Microsoft enriched the data. This is the raw data that's available. It's also important to know that because later on, if you do a proactive threat hunting, then you can use that raw data to start creating your exposures. So we got the user account. You can also see some additional information about the user, like for example, which group it is part of. And then we can go to the next relationship. That user account can authenticate to a device. And if you have a look at the device, it's currently a normal device, but on that device, there are some vulnerabilities. So here's it, the user can authenticate to the device has some vulnerabilities. So quickly out of the portal, you can see some vulnerabilities that are available. And again, over here, that device that is vulnerable has credentials of a user account. And what you see here is the MTLM hash. So the local security authority process in the memory mostly has the MTLM hash available over there, and that can be abused by a user. And then that device has those credentials, and what type of user it is, you can see over here, it's a privileged user with high permission in your environment. And of course, that user that can authenticate to another device, and in this case, that other device is the domain controller. And you can see it with the all data you got over here. You got additional information about that endpoint, and you can see it's the domain controller. I'm already 34 minutes left, so I got only 10 minutes left, and I got still some 30 slides to go. So let's quickly go around the attack map. So attack map is really to find the blast ratios of your entities in your environment. That can be user accounts, they can be groups, virtual machines, key vaults, storage accounts, encryption. So there's a lot of data available. This is an example of domain controller attack blast ratios. If you what I did here, I searched the domain controller, and what you can see over here, that is a critical device because it's a crown on it, and it's also exploitable, or there is some vulnerabilities available on that device because you see it with the icon over here. And then you can see what type of blast ratios there is available. You can see that it has credentials of user Terry. But also what you can do is if you can start expanding this and see how the blast ratios of Terry is. And if you do that, you can see different relationships that are also created in the environment. What you also can see are the other attack paths that are available against Jerry, and so we can see how that can be misused in an environment and how you can resolve that those attack paths don't exist anymore. You see, there's also something cool is that it's really hybrid. So this is an example of a vulnerable device which has some exploits available, and that device has the intra-user cookie of the user Jerry. So that's another attack path that can be misused by an attacker, and it can easily be found in the attack map solution. Let me quickly go over this. Okay, so that was the attack path. Another thing that's available is if you want to do proactive exposure management hunting. So what's available in advanced hunting are two tables. We got the exposure graph nodes. So that's all the entities in your organization. That can be devices, users, user groups, virtual machines, and so on. There is also an additional table available, the exposure graph edges, and that's the relationships between the nodes. So that can be, like I showed you before, has credentials of, and that is a relationship. Those are available over there. So what I really suggest to do is start using those tables and start very basic. Just print out the table and distinct on the node label. And the node label are the nodes types that are available in your organization. If you see over here, I hope it's readable, it's 49 items that are currently available in my test environment. And it can be everything. It can be, as you see over here, anti-user cookies. It can be groups, it can virtual machines, subnets, and so on. That's all that data is available to do proactive hunting in your environment. Something else that's I told you before is the raw data, and the raw data is also very important to create your use cases. And you can see it in the node properties column. And the node properties column is an JSON file. For the old people, JSON is the XML for the young people. And here is an example how we can use the exposure graph nodes. So what I would like to hunt for is discover internet faces devices with privilege escalations vulnerabilities. It's a basic example, but it will tell you how powerful it is. So you got the exposure graph nodes, and here I'm going to use that raw data. And in the raw data, it's available is internet facing, and also vulnerability to privilege escalation is available. Of course, I only want the category devices. And if I run this query, it will print out every device which is the internet facing with a privilege escalation vulnerability available. Another hunting that you can do is discover virtual machines exposed to the internet with a remote code execution vulnerability. And the same principles goes here. We got a raw data exposed to the internet, vulnerable to remote code execution, and we want the category for virtual machines to be available. What we also suggest to do is have a look at the relationships that are available. So again, here, very simple. We start using the exposure graph edge table, and we distinct on the edge label. And the edge label are the edge types or the relation types that are available. So here you can see, can authenticate day 2, affecting, has a role on, has credentials on. So all those type of relationships can be used to create your own, or if you want to start hunting on your own. And here's another example from these relationships. So I start hunting, and I want as a source my devices, and I only want to use the edge type has credentials off, and the target has to be a user. So this gives me very quickly all the devices that has credentials of a user. Maybe it's a basic example, but I think it will be more clear how you can start using those tables. And again, over here, you got your edge properties, and that's the raw data. And as you can see over here, it can be an endl in my environment, but also a primary reface token that's available. Now, what you also can do, you can start creating your own graphs. And with this, you need an operator. It's called the make graph operator. And this will generate a graph structure for you, but only in memory. So the output is not usable. And for this, you need another operator. And it's a graph mat operator. And there you can define the nodes and the edges between the nodes. But let's explain this with an example. So I want to hunt to all devices with a vulnerability and has credentials of a user credentials with an attribute admin count. So admin count, it can be set to 1 in Active Directory. So it's an attribute in Active Directory. And when it's 1, the user has privileged credentials in your Active Directory environment. Simply said. So I want to hunt for those. And let me start with the exposure graph nodes. And what I really suggest to do is start filtering early in your hunting. So I start already filtering because I only want devices which have vulnerability insights, and that's the raw data that's available, or I want identities with the admin count to 1. But then you can start creating your graph with the exposure graph edges. And first of all, you need a common identifier. So we got our source node ID, that's the identifier, and the target node ID from the table full. It is a temporary table I created over here, which the filtering of the nodes. And then you can start creating your relationships. And this is a very, very basic example. You see over here the graph mat operator. You got your source node, edges, and target node. As you can see over here, the name source node, edges, and target node, you can choose on your own. So it doesn't have to be a naming convention from Microsoft. You can create here your own names. And to keep it simple, I want my edge label. So on my edge labels, I want only to have a graph with has credentials off, and I can print it out. And so that easy it is. So what I have over here, I have all devices with a vulnerability that has the credential of a user. and only the users with the admin attribute admin count to 1. What you also can do is create more of longer graphs of longer attack paths, and you can accomplish this with defining your edges. And with this syntax, you can choose that you only want attack paths with 2 to 3 relationships long. So in this example, I want only to create attack paths with 2 to 3 relationships long, and I want only to use the edge type has credentials of, member of, has role of, can authenticate to. So what the query will do, it will start creating graphs and start finding the relationships with only the edge labels I defined here. And as a target, I want virtual machines, and as a sort, I want a user. And then if you print this out, you will see that you will get all the graphs that are currently available in your environment. So I can see over here, you got your source, which can authenticate to. So it's mostly a user that can authenticate to a device. The device has credentials of, and then of a user, and that user can authenticate to another device. So as you can see, there are a lot of possibilities. There are a lot of use cases, and you can start using this to hunt to the exposure of your environment. So that is the last example of it. Show client devices with critical vulnerabilities or users that have access to high-value servers. So as I said before, start filtering early on in your process. So what I did over here, I want only the devices which has a critical level, and I only want devices, and this with the or devices with vulnerable to remote code execution. And I also want my identities. And so I did already early filtering. And then I want to create my edges. What you can also do is to reduce the number of edges is also start filtering from the beginning. So I want only edges with can authenticate as and can remote interactive logout to. That's also a relationship that's available. Then I got my identifiers, and then I can create my paths. And so as you can see over here, I created a path. This devices with remote code execution, that's the source. Then the first relationship has to be can connect as an identity, and then identity can remote login to a critical device, and that's our target. And the targets are the high-value servers. As I said before, the names that you use over here, you can choose your own. It's all totally up to you. And here you can define the edge types that you want to use. So for the can connect as, I want can authenticate as a relationship. Can remote login, I want can remote interactive login. And here I identify my identities, but also the devices with the high vulnerabilities of it in critical level high. And then I won't print it out, and I get the output of every client device with a critical vulnerability or the users that have access to a high value server. So as you can see, you can do a lot of things proactively and proactive exposure management. So it's what I suggest: start start experiences and have some experience with it, because it's a lot of fun to hunt after those exposures. Something that you will come up to, because it's only 45 minutes left and I need to stop. But there's also a resource limitation. So that's why I said before, start filtering early in your process, because you want to you don't want the resource limitation happening in your environment. So that was the exposure graph. Now the last thing, the exposure insights, and let me quickly show that with a demo. Okay, so as I told you before, you also need those insights, and your insights you can find on here on the exposure insights, and there you got the initiatives. And the initiatives, you really need to think about it like it's a security program. So here you got a lot of examples, and it's mostly we got domain initiatives and threat initiatives. So this is my test environment. It's not something special, but you can start using those as a security program. For example, if you want to work on your cloud security, you can start looking at those, and you can see a lot of security recommendations over here. Something good to know is also Microsoft called this secure score on steroids. So if you have a look at the Microsoft talk about this, they talk about it as secure score on steroids. I can give you then it's more advanced than, of course, security score. You get your security recommendations. Those are mostly action-based. You get your security metrics, and that's are mostly value-based. But as you can see over here, you got a lot of options over here, and also at some time you will see here on the top that there are new versions of those available. And then you click on it and you can review the update. It's interesting that you have a timeline, and it's mostly 40 days. So you can see if you have you need to report to management how your posture management increased or how it's improved. Then you can show it all the data which are available over here. And the progresses can be used for that. What you also got are the threat indices, but I cannot show you this in my environment because it's very basic. And over here you got the metrics, so that's more the detailed metrics. And you also got the recommendations. And what also is very handy, I find, is that you can filter on the workloads. So if you want to have a look at some kind of workloads, like for example, Defender for Office, I don't know, it's a good idea, let's have a look. You can see that in my test environment, I got a lot of work to do to improve our posture management about the domain or about the workload Defender for Office. And at last here, you got also a lot of events, and here you can also use this to show you to the management board, to the management, if you want to report to the management, you can use this to report, and you get an overview of how your exposures are increased over time and how it gets more mature over time. So that was it. This was my last slide. I did a little bit over time, only 5 minutes. So I hope it's okay. I hope it was interesting, and don't know if there are some additional questions.
First of all, thank you very much. 5 minutes overtime is pretty okay. It's basically full in range, and that is what we expected. So, well done. Yeah, Ugo, do you have any questions?
We don't have any question in the chat, but I do have one. Thomas, so I expect people to or want to enrich the data with external connectors. On one slide that you had, you mentioned that this is still preview, right? And do we know what that pricing will be after preview? Is there any details? Because I imagine if you're a bigger enterprise and you do have ServiceNow, for example, connected with the CMDB or Tenable, those assets will sum up and increase the license costs, right?
Yeah, correctly. Yeah, so currently there is not a price available as far as I know, but it's consumption based per asset. So if you import your whole CMDB, I think it will be a lot of cost. The license will be increased. So, but that's still not information that we have. At least I don't have. But yeah, it will be announced soon enough. So we will see.
I hope that they will inform us beforehand before they set it to consumption based. Yeah,
we will see.
It can be expensive, right? So
yeah. Especially in big environments, and I couldn't test it because currently it's free. So I'm really curious what the cost will be.
Maybe it's somewhat comparable to the external tech service management. This is also asset management based, and there's some pricing. I just looked it up right now. Let's say let's go to Germany North for whatever reason, and it's not available there. Interesting. Thank you very much. Okay, Germany West Central, and we have it in euro. It would be 1.1 cents per asset and day. So 33 cents per month and asset for the external tech service management. So I would assume it would be something like that in the range of, or, and this is what I would like way better, maybe they go for the Defender IoT pricing where you have the site-based price. That I would love way more than that consumption-based stuff here. But we'll see.
That's very good feedback. Maybe you need to tell Microsoft about it.
Yeah. Microsoft, if you see that, call me. I can give you tips on pricing.
Under NDA, of course, right?
Absolutely.
And Thomas, one more question. The queries that you showed, are they accessible? Are they shared anywhere?
Yes, I got it on my GitHub. I got it available. Let me put it in a chat.
Perfect. That's what I wanted to ask also, because I think you have a lot of knowledge there already.
Can you guys paste it in the chat? I did it in.
Yeah, I'm displaying it now on the stream.
Perfect.
And
so
perfect.
In the future, I hope to add more of those type of huntings. Yeah.
That's GitHub, so everybody can contribute if you want. So if you're out there trying it out, finding some interesting queries, put them in. I think there are a lot of great summaries on GitHub, especially for all the KQL stuff on Sentinel. Why not do the same thing here also? Create that base and share the knowledge, because I think there are so many topics at the moment, and it's getting broader and broader, so we should all share what we can. So, okay. Thomas, thank you very much. I found it really interesting. I hope for you two guys to be back someone in the future, maybe with an even more automated approach on managing Linux certificates with Intune. Maybe do something on Linux servers also. So finally bringing Intune to server management. We will see. Thomas, thank you very much.
No
very interesting. Share your things, and maybe you can give us an update on pricing when you have it finally, or when it's finally available. Maybe also just notify us on our LinkedIn page, and everybody watching, I have to do that YouTube thing now. Like us, follow us, and in Germany we say abonnieren, subscribe. You have to subscribe to ring the bell. Sorry, I had to do that. Thank you very much. Next time, Google, do we have the date already? I think we have, right?
Yeah, we will share it also. It's the last Thursday in March.
Yeah, it will be March 27th then.
All right. Yeah.
So mark your calendars, and we will set up the CFP for it very, very soon.
Thanks,
Have a great time. Thank you, everyone.
Bye-bye.
Bye-bye.